In this presentation, I'm going to introduce probabilistic procedure planning in instructional videos with weak supervision. My name is He Zhao, and this is a joint work from Samsung AI Center in Toronto and York University. In this work, we study a problem called procedure planning, and it is defined as, given a start and go video clip, our mission is to carry out a plan which can interpolate them with a sequence of transitional actions. In this example, we are given a raw steak at the start and a cooked steak at the go. The desired model should outline a sequence of actions such as add seasoning, open lid, put steak on grill, and then cut steak. This is a feasible plan from instructional videos online. The difficulty in this direction is to automatically learn such ability by just watching videos. We found this task quite challenging to be used in real life. The first challenge is how to learn a model with minimum supervision, because current approaches have to rely on intermediate middle state as supervision. This requires knowing the start and end time for every middle step, which costs massive annotation efforts. And the second challenge is model the inherent uncertainty in the task, such as different video posters would have done the same task in different fashion. No current approach has a probabilistic inference mechanism. And the third one is having a compact and efficient inference model. Existing methods use an autoregressive two-branch framework, which harms the long-term performance due to build-up error and slows down the inference speed. To overcome these challenges, we made 3 contributions. We explore a weak supervision from natural languages, which is much easier to have. And we introduce a probabilistic model to capture the uncertainty. We also propose a novel memory-augmented transformer decoder to produce all procedure plans in parallel. The key to achieve the weak supervision is to replace the visual features with language embeddings. The former one needs annotations on the start and end time, whereas the language embeddings only need the order information of action steps, which is much weaker. This can work because of the recent development in video language joint modeling, where features of different modalities are embedded in a much closer space via contrastive learning. In our approach, both of the visual and the language representations are from such a joint space. To have a probabilistic and non-autoregressive model, we devise our plan generator as following. We first contrast the input with a combination of start-go observations, learnable queries, and Gaussian random noise. Then a stack of transformer decoder augmented with a global memory will produce the entire plan at once. This memory module interacts with query input via cross-attention, and it is shared across all the layers and the entire dataset for better efficiency. We train our model with a combination of 4 losses. The first is an action class classification loss, and second is a weak language contrastive loss. And the next 2 are for meaningful probabilistic modeling, which is a adversary loss to promote realism and a regularization loss to encourage diverse predictions. Here is a quantitative realization of our ability to infer multiple plans given the same start and goal. The start state is an empty bowl, and the goal state is a cup of beverage with a few empty shots. Our model infers 3 plausible paths. You can first pour powder, then water and juice, and finally stir them well. Or you can choose to do it in different order or with different ingredients. No other model is capable of doing that. We evaluate our approach on 3 instructional video datasets, that is, the CrowdTask, the Corn, and the NIV. The Corn is the largest and the NIV is the smallest. We choose them to show that our model is scalable to different sets of datasets. We compare our approach against 7 different algorithms and consider evaluating on both probabilistic and deterministic metrics. Our model set a new state-of-the-art result on all datasets and metrics, even with less supervision. In summary, we introduced a weakly supervised approach for probabilistic procedure planning using instructional videos. We show strong performance with weak language supervision and demonstrate the crucial role of modeling uncertainty. Our approach improves planning performance on all considered datasets and metrics. If you are interested in our work, please visit our project page.